In this session, we are going to look at what we call linear functions. Now, a linear function is just a polynomial function whose highest exponent or whose highest power is 1. And of course, linear functions you can write them in form of this. This is ax plus by plus c. In this case, a, b, and c are constants. This is equal to 0. Or you can write it in this form: y is equal to mx plus c, where m stands for the gradient of that linear function and c stands for the y-intercept. By linear function, the other way is more of a straight line equation, an equation of a straight line. And when you're dealing with straight line equations, the highest power of x is always 1. And that is what qualifies it to be a linear function. So definitely, if you look at our write-up here, this is one form of expressing the linear function. You can express them in this form. And of course, this is coming after making y the subject of the formula in this expression. When you make y the subject of the formula in this expression, we end up with this expression. And this expression, if you look at it closely, it's exactly in this form, where negative a over b is the m and c, negative c is right there, the y-intercept. In writing the equation of the line containing 6, 5 and having that slope of 3 over 4, I'm going to write this equation in two forms. There is what we call the point slope form, and then there is what we call the slope-intercept form. So we'll begin with the point slope form. Now, with the point slope form, the form looks like this: that when you're writing the equation of a line, it's going to be y minus y1 is going to be equal to m into x minus x1. Now, the value of m here stands for the gradient, and these points y, the points y and x right there are just arbitrary points. It's an arbitrary point, x comma y, and then y1 and x1 is more like the point that is given. For example, in this question, we have 6, 5. So our point 6, 5 becomes our point x1, y1. And so we're simply going to come and substitute it in here. So it means this is going to become y minus our y1. Our y1 is 5. That is going to be equal to our value of m, which is the gradient. It is given, or the slope, it is given as 3 over 4, into our value of x, which is an arbitrary point, x minus x1, which is 6. And this becomes the equation of the line. It's our answer. And now this is the point slope form of the equation. We can write this equation another way. We can write it in the slope-intercept form. And now when we're writing it in the slope-intercept form, this is when we'll use the general equation of y is equal to mx plus c. That is the point slope form. Now we are going to look at the slope. In the slope-intercept form, it is y is equal to mx plus c. The value of m stands for the slope or for the gradient, and then the value of c stands for the y-intercept. So right here we have the point 6, 5. So what we are going to do, we are going to have to first find the value of c. So we are going to substitute. This is the value of x, that's the value of y. So the value of y in this case here is 5, is going to be equal to the value of m, which is the slope or the gradient, which is 3 over 4, multiply that by the value of x, which is 6, plus c. So definitely this is going to give us, by 2 this is going to give us twice, by 2 this is 3, this is 3 times 3, which is 9 over 2, is going to give us 5, that is plus c. And definitely this is going to end up, our value of c is going to be 5 minus 9 over 2, and our value of c is a half. So after getting our value of c as a half, we have value of c. So we bring back this equation and we shall say, therefore our value of y is therefore going to be, our value of m is 3/4 of x, and the value of c is plus a half. So that is the equation of that line, and this is the equation in the slope-intercept form. So you can write the equation of this line either in the point slope form or in the slope-intercept form. it will still be correct. So in this question, they're asking us to write an equation of the line containing 1, -3 and -4, 2. So in the slope-intercept form of the equation, y is equal to mx plus c is the general form of the equation. So it means that we are going to first have to find the value of m, the slope. After finding the value of m, then we shall go ahead and use one of these points to find the value of c. Then we shall substitute everything here to get the general form of the equation. So we first find the slope. And the slope here, the equation for the slope, or the formula for finding the slope, is y2 minus y1 over x2 minus x1. That's going to be y2. Now let's call this our x1, y1. This is our x2, y2. So our y2 is going to be -2 minus our y1, which is -3, minus -3. Divide that by our x2, which is -4, minus our x1, which is 1. And definitely there we are going to end up with, this gives us a plus, -2 plus 3 is 1. Divide that by -4, and -1 is -5. So our answer is -1 over 5 right there. So that's our slope. After finding our slope, go ahead and find the value of c, the y-intercept. So from y is equal to mx plus c, we shall just get one of these 2 points. One of these 2 points, let's get this one of 1, -3. So we're going to substitute it in here. So our value, this is x, this is y. So our value of y here is -3, so we shall say -3 is going to be equal to our slope, which slope we already got as -1.5. So it's going to become -1.5x. Our value of x here is 1 plus c. So this is going to become -3 is equal to -1 over 5 plus c. So making c the subject for the formula means it's going to be -3 plus a fifth. This is over 1. Our value of c is going to be So our value of c is -14 over 5. So definitely the equation, after getting our value of c, the equation is going to become y is equal to our value of m, which we got as -1 over 5x plus c. This becomes -14 over 5. Okay, so now I would like us to discuss parallel and perpendicular lines, and how these two relate with the gradients of these specific lines. Right before us we are having 2 sets of equations, those that are in red and those that are in green. Now if you look at these sets of equations, they are all in the form of y is equal to mx plus c, and we say that that's the slope-intercept form of the equation. And we say that the value of m is representing the slope of the equation and c is the y-intercept. Now if you look at these ones that are in red, you'll discover that the value of m is the same. This is y is equal to mx, the value of m here is 2, and the value of m here is also 2. So when you look at these 2 equations, the value of m is the same. But when you look at these other 2 equations, the values of m here are not exactly the same. They are just changing the signs. For example, if you look at this, the value of m is 5 over 2, and the value of m for this one is -2 over 5, or by value of m I'm talking about the slope, the gradient of the line. Now, in this first case, when the value of m is the same, it means that these 2 lines are parallel. So let's take it from there, that the parallel lines have the same gradient, or parallel lines have the same value of m. So that is how you tell that one line is parallel to another, when their gradient is the same. Now when you look at these 2, their lines, if you get the value of m here and the value of m here and you multiply them, you're going to get -1. For example, you find that the value of m here is 5 over 2. If I multiply 5 over 2 by -2 over 5, the answer I will get is -1. So with perpendicular lines, when you multiply their gradients, you're going to get -1 always. So it means that if the gradient of this line, let's say, was 6, the gradient of this line will be the negative reciprocal of this. So it will be negative 1 over 6. Why? Because 6 times negative 1 over 6 gives us negative 1. If the gradient of this line was, let's say, 4, the gradient of this line will definitely be the negative reciprocal of this one. So it's going to become negative 1 over 4. Why the negative reciprocal? Because when you multiply these two gradients, they should give us a negative 1. If the gradient of this line, let's say negative 6, it means the gradient of the other line will be the reverse of this reciprocal. So it will be positive 1 over 6. Because when you multiply those two, it's supposed to give us negative 1. Maybe one more example. If the gradient of this line was a half, it means that the gradient of the other line is going to be the negative reciprocal of this. So it's going to be negative 2 over 1. When you multiply these two, it's going to give us negative 1. So that is the rule. When we're dealing with parallel lines, their gradients are always going to be the same. When we're dealing with perpendicular lines or lines that meet at 90 degrees, when you multiply their gradients, the answer you should get is negative 1. And the easy way to figure out the gradient of the other line when this other line is not been given is by simply quoting it as the negative reciprocal of the other, or call it the reverse reciprocal of the other. So to illustrate that further, we have a question here. Write an equation of the line containing 1, 7 and is parallel to 3x plus 5y is equal to 8. First of all, we know that parallel lines have the same gradient. So we are going to first rewrite this equation in the form of y is equal to mx plus c, so that we are able to tell the gradient of this line. So this is this line we want. The line that we are looking for is passing through this point, but this same line is parallel to that. So let's rearrange this equation. This equation is 3x plus 5y is equal to 8. So we are going to make y the subject of the formula so that we put it in the form of y is equal to mx plus c. The reason for that is that so that we are able to find the value of m, so that we are able to know the gradient of that line. So that, because when we know the gradient of this line, then we can tell the gradient of the other line whose equation we are looking for. So it's going to become, this is going to become 5y is going to be equal to 8 minus 3x. And when we divide through by 5, by 5, by 5, this goes with that, remain with y here. Our value of y here is going to become negative 3 over 5x plus 8 over 5. So meaning that the line we are talking about here is negative 3 over 5. So now the gradient of the line we are talking about here is negative 3 over 5 plus 8 over 5. So meaning it's going to be, the gradient is negative 3 over 5. Now the question is telling us that write an equation of a line that is containing 1, 7. So it's going through 1, 7 and is parallel to this line. So now if it is parallel to that line, the line we're talking about is this one right here. So it means that this is the gradient of that line. If the gradient of that line is negative 3 over 5 and this line is parallel to the line we're looking for, it means that this line we're looking for is also having the gradient negative 3 over 5. So we already have the gradient of the line we are looking for as negative 3 over 5. Now that we know its gradient, we can go ahead and find the real equation of the line. So we shall say that other line we are looking for, y is equal to mx plus c. So that line we are looking for, we have one of its points, it's 1, 7. So y is 7 is going to be equal to the gradient m, which we have here as negative 3 over 5. Negative 3 over 5 times the value of x. X is 1 plus c. So we are trying to look for the value of c. So definitely this is going to become 7 is going to become negative 3 over 5 plus c. When we make c the subject of the formula, c here becomes 7 plus 3 over 5. So our value of c is 38 over 5. So to go ahead and write the real equation of the line, our equation is definitely going to end up being y is equal to our value of m, which is the gradient, which we got as negative 3 over 5x plus c, which is 38 over 5. So here we are required to write an equation of a line that is containing this point and is perpendicular to y is equal to 4x minus 5. Now, these are lines that are perpendicular to each other. They meet at 90 degrees. What do we know about perpendicular lines? When we multiply their gradients, it is equal to -1, the answer we get. So this is in the form of y is equal to mx plus c. And the value of m in this case here is 4. So if the line we are looking for is perpendicular to this line and the gradient of this line is 4, it means that the gradient of the other line we are looking for is the negative reciprocal of this. So it is negative reciprocal, so it's -1/4. And when you multiply those two, 4 times -1/4 should give us -1. So it means that that gradient of that other line is -1/4. So now that we have the gradient of that line, so now we can go ahead and find the y-intercept, the value of c. So we know that y is going to be equal to mx plus c. So now what's the value of y? We have, this is x, y, our value of y is 2, so 2 is going to be equal to m, which is the gradient, which is -1/4, times our value of x, in this case, which is -3, plus c. So we go ahead and find the value of c. So this becomes 2 is going to become -1 times -3 is +3/4 plus c. Our value of c in that case is going to become 2 minus 3/4. Now that we've got our value of c as 5/4, we can go ahead and find the equation of that line. So we know that the equation of the line is y is equal to mx plus c. So it's going to be y is going to be equal to our value of m. The gradient, we got it as -1/4, so it's -1/4x plus the y-intercept c, which is plus 5/4. And this right here is the equation of the line that is containing -3, 2 and is perpendicular to this. So we've been given point 2, -3 and point -5, 4. Find the length PQ and the coordinates of the midpoint. So we have this line right there. It is having point 2, 3 and it is also having point -5, 4. We are supposed to find the length and then the midpoint. First of all, to find the midpoint, let's first find the midpoint. The midpoint, we shall get the midpoint from x1 plus x2, divide that by 2, y1 plus y2, divide that by 2. So now our value of x1 here, let's call this x1, y1, and this is x2, y2. So it means that our value of x1 in this case is going to be 2 plus x2, which is -5, divide that by 2, y1 is 3 plus y2, which is 4, divide that by 2. And our answer definitely there is going to become -3/2, 7/2. These are the coordinates of our midpoint. Now to go on and find the length PQ of the coordinates. Length of the coordinates, this was -3, this is 2, -3, so there's a -3 there. This is -5/4. So this 3 right here is supposed to be -3. So -3 plus 4 makes this a half. So the coordinates are -3/2, a half. That was a small error there. This is a -3, not +3 like we had earlier put. Now when you're trying to find the distance of a line, we are going to use Pythagoras Theorem, but I would like to first show where it's coming from, then we'll go ahead and calculate. If this is our straight line right there, let's call this x1, y1, and this is our x2, y2. We form a right angle triangle right there. So it means that to get the distance from here to here, let's call this distance AB, or this is PQ. So this is distance P, that is distance Q. To get this distance here, it means that we're going to use the Pythagoras Theorem. This side squared plus that side squared is going to be equal to this side squared. So to get the length of this side, it's simply going to be, this is the y-intercept, so To get this, it's going to become y1 minus y2. Then to get the distance here, this is the distance of on the x line, it's going to be still x1, the value of x here, minus the value of x here. So it's x1 minus x2. So it means that for us to get the distance PQ, it's going to be PQ squared, which is going to be equal to this side squared, which is y1 minus y2 squared, plus this side squared, which is x1 minus x2 squared. And definitely the general equation is going to be PQ is going to be giving us under the square root of y1 minus y2 squared plus x1 plus x2 squared. This is the general equation we shall be using when we are trying to find the equation, or when you're trying to find the length or the magnitude of a line. Call it the length of a line or the magnitude of a line. So in this particular question, we are having the 2 points, and it's just a matter of substituting them in here, and we get our distance PQ. And this is how we'll go about it. So for us to get PQ, we have, this is point P, this is point Q. We have our point here as 2, -3. We have our point Q here as -5, 4. So to go ahead and find the distance here, the distance PQ is going to be equal to under the square root of y2 minus y1. Let's call this x1, y1, this is x2, y2. So y2 minus y1, so it's going to become 4 minus y1, which is -3, this is squared, plus x2, which is -5 minus 2, and this is also squared. So we shall end up with, this is going to become 4 plus 3, which is 7, 7 squared, plus -7 squared, and this is going to become 49 plus 49. This is going to give us the square root of 98. So the length of PQ is simply the square root of 98. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia, helping you manifest excellence.